Hey everybody, it's Miss Kathy from the Merrimack Public Library, and this is a special two-part Elementary Explorers. I am hoping to help you use up some of your Thanksgiving leftovers with two different types of cranberry science. So the first science experiment we're going to do is going to be a take on the dancing popcorn experiment using dried cranberries instead. So we have some dried cranberries. We're going to need vinegar and baking soda and water. And that's one version of the experiment. And then we're going to do the same one. We're going to use the same cranberries with a clear soda that I've also put into a small bottle. You can see that it's very bubbly. So we're going to do it two different ways. One using a clear soda and one making our own carbonation using baking soda and vinegar. So we'll start with the bottle that has the soda already in it, and you can see that it already has some bubbles because of, like I said, the carbonation. That is carbon dioxide that's formed in the liquid coming up to find the surface to release those gas bubbles. That's why carbonation makes your drinks bubbly. And we're going to take some of our dried cranberries and see what happens to them. Oh, can you see what's happening to the cranberries? Why do you think they're moving up and down? So this is happening because when we added the cranberries, you can even see the surfaces are very bubbly on the cranberries. So when we added the cranberries, those carbon dioxide bubbles clung to the surface of the cranberry. It lifts the cranberry up as the bubbles want to get to the surface to release the gas. When the cranberries get to the surface, the gas is released, and then when enough of the bubbles pop, the cranberry falls back down to the bottom of the bottle, where slowly more gas bubbles attach to the surface of the cranberry and lift them back up again. So that's pretty cool, but we didn't have to do a whole lot of work for that one. So we're gonna do it again and be a little more involved this time. So I have a bottle of water, and to this bottle of water, we are going to add some baking soda. So the first part of this is going to be dissolving a solid into a liquid. In this case, dissolving the baking soda into the water. And I think the easiest way to dissolve this is going to be putting the baking soda in the water and then just shaking the bottle. And for each combination of liquid and solid, there's only a certain amount of the solid that you're able to dissolve. So I added about 2 teaspoons of baking soda, and you can see that it has left a foam kind of at the top of the bottle, but there's not a whole lot of powder floating around. So it seems like it's dissolved enough. So I'll take the cap back off we'll add some cranberries. And they are just chilling at the bottom of the bottle right now. But let's see what happens when we add some vinegar. I know that many of you are already familiar with the reaction between vinegar and baking soda. What happens? That's how we make our volcanoes, right? So let's see. I have my vinegar in this little eyedropper, so I can add it a little bit at a time. And I'm going to hold it over this container in case it spills. Okay, that's not much of a reaction yet. We're definitely getting some bubbles at the top. Oh, we had a cranberry float up for a moment. So we must be heading in the right direction. Ooh, okay. There was definitely more of a verbal reaction there, or a audible reaction. It's bubbling, I can hear it. And I can see at the bottom there are bubbles forming on the cranberries, but they're not floating yet, which could be. Oh, okay. Now the bubbles are all the way up to the top of the bottle, but still not much of a reaction, which tells me that maybe my ratio is off. So I'm gonna pour out some of the water. I'm gonna add more baking soda. Even though the cranberries are in here, so it might be harder to dissolve it this time. But science is nothing if not a little messy, especially science with me. So let's dissolve some more baking soda. And see if we can get a more dramatic reaction. Okay, that was a pretty good reaction. I can hear the fizz as the gas forms, and we have a floating cranberry. Now we have a few. We have like the little pieces of cranberry are floating, but the full-size cranberries are not yet. But I can see there are bubbles starting to form. Oh, there goes one. And right back down. So this version, like I said, it's more work. We get to be a little more hands-on because we have to get the ratio right to form our own carbon dioxide. Now they're moving. So it takes a little bit of trial and error, which I happen to like in a science experiment, because you can hypothesize what you need to get the reaction you want and play around with it. And I am surprised by how much vinegar it's taking. So I can't wait to hear, if you try this at home, what your experiment looked like. There we go. Okay, we got there. We had to play with it a little bit, but that's the fun part of these experiments. So, and our cranberries and soda, they're still dancing away. They're still having a great time, which is also kind of surprising that it's still going and the gas isn't releasing, but that could be because I put the cap back on in case I accidentally jostled the table. I didn't want it to spill. So the gas doesn't have anywhere to go. So it's trapped in the bottle with the rest of the soda. So I think this definitely gave us a more instantaneous reaction, and it's a little bit more of a prolonged reaction, but I still like this version because we got to play around a little bit more. So that is one part of our cranberry science, and I'll be back with another video tomorrow where we are going to make oobleck using cornstarch and cranberry juice. So oobleck is a Newtonian fluid, which means that it has properties of a liquid, but also properties of a solid. And you'll see what we mean when we make it tomorrow. Have fun with this experiment if you decide to do it. Let me know what your results are and how long it took you to get the ratios right. And we'll be back with another science experiment tomorrow. Thanks, everybody.